Blast, bringing land and sea together. Work Package 3, developing a marine and coastal reference base. Bringing land data and sea data together is not an easy task. The focus of Work Package 3 in the Blast project is on developing one seamless land-sea reference base that can be used for the planning and operation of multiple and sometimes conflicting coastal and marine activities. Our challenge was to assess the many datasets and mapping layers that already exist across the North Sea region and bring the most suitable of these together, filling the gaps where necessary and harmonizing content into a seamless data layer across the land-sea zone. This is a major undertaking, as not only do different groups such as navigation, conservation, geology and hydrography all map the world differently, they also vary in approaches across regional and national boundaries. So how did we do it? The first and most important input for this work is the data. Over 100 datasets existed across the project area, and each was systematically assessed for suitability for the project. This required formal metadata records for each dataset to be created where these did not exist, and registered in an online metadata portal. The data covered physical features such as pipeline and wreck locations, and also non-physical features such as administrative or restricted zones. We sourced much of the data for the project from electronic navigational charts, but because these charts are created for navigational purposes, work had to be undertaken to identify which features were to be used in the project and which of their attributes were of most interest to users. After assessing the data, the product specification for the land-sea reference base, as well as the data model to house the inputs and outputs, were developed in the database. The product specification was developed into a user-friendly feature catalogue and application schema. Differences in coordinate reference systems, feature encoding, data collation techniques, feature type depictions, and data-scaled capture periods all posed challenges to us. But one of the most significant obstacles we faced was the lack of high-resolution data in some coastal areas. We developed survey specifications to fill these gaps, and local hydrographic offices across the project area collected the data. Surveying was undertaken using a variety of airborne, land-based, and waterborne sensors, with the aim of obtaining bathymetric and topographic LiDAR and multi-beam data to use as input into the elevation surface layer. The results could be assessed to determine which techniques worked best for different areas and under specific situations. Another significant challenge in the project was the numerous vertical datums that have been realized across the Blast project area. Some of these are inherently defined for the whole land and sea area, whereas others are only defined for a sea area, for a land area, or for specific river and fjord areas. The challenge has been to link all these different types of vertical datums with each other. In doing this, we had to understand the various realizations of the datums and understand their definitions, which are related to their practical use and the human activity associated with them. For example, users of terrestrial data may want to know if a certain point on the Earth's surface is above or below the sea level, to understand if an area could be flooded. Users of marine data may ask, what is the depth to the sea bottom at a particular position and time, to understand if an area can be navigated at any time other than high tide. In addition, national realizations of the vertical datums are often based on national data only, and thus will be inconsistent when extrapolated across the national borders at sea. In fact, the national vertical datums are often not defined across the national borders for this reason. Incoming project datasets could be referenced to any one of these vertical datums. Based on 12 years data from satellite altimetry, enhanced and modified near the coast, a regional mean sea level model and a lowest astronomical tide model were created for the North Sea area. Using these surfaces and a European quasi-geoid surface for the entire land-sea project area, work was undertaken to define the transformations between the various vertical datums and develop an application to allow users to perform these transformations. When using this application, users can not only transform marine and terrestrial data to one common vertical datum in a local geographical area, but also transform data between different various national vertical datums across the project area. The development of a new methodology to bring together all the various data sources was key to the success of the project. As well as the data transformations, additional processing tasks were required, such as topology editing, to ensure features behave as they do in the real world, such as marine features not appearing on land. Feature deconfliction, to identify the feature to keep where duplication exists in several datasets. Feature attribution and encoding, to ensure features are encoded and attributed correctly in the final output. SeaZone developed a range of processing tools to upload, manage and manipulate the topographic data and integrate it into seamless data layers for each pilot site. Our expert modelers transformed the marine and terrestrial bathymetry and LiDAR data to a common vertical reference and modelled the data using Delaunay triangulation techniques to form a seamless surface. The output of this work was the development of a coverage view of the world for the elevation data and a feature view of the world for topographic data. Both of these distinct views are seamlessly joined at the land-sea boundary. So, we have developed one seamless land-sea topographic data layer for each pilot site, and one seamless elevation surface for each pilot site, which can be layered on top of one another in a GIS, database, or used in specific applications, such as a spatial planning tool. Using this project methodology, data interoperability can be achieved across national boundaries, at the coastline and offshore, and the practical implementation of the data integration methods can be scaled up or down to suit a project's geographical area of interest.